Alright, so this is similar figures notes. We just talked about the difference between similar and congruent. We did congruency already. Congruent figures, the size and the shape was the same because the angles were congruent and the side lengths were congruent. On similar figures, only your shape is the same. Your side lengths will be different. Similar figures, your side lengths are different, your shape is the same. What makes the shape is the same is the angles. So on both similar and congruent, both of those, your angles are going to be the same. The difference between similarity and congruency is the side lengths. Congruency, your side lengths will be exactly the same on both figures. Similarity, the side lengths will not be the same, but they will be proportional. So, what is a ratio? A ratio is a comparison of two or more quantities. Ways we can write a ratio. We can write a ratio as A colon B. This is saying A to B. Now the letters I'm using are just placeholders for numbers. We're not using any numbers. So A to B. Or we can write it in words, A to B. And the way you'll see it most in this unit would be as a fraction, but it reads A to B as well. A over B, same thing as saying A to B. This is the way you'll see it most in this unit. Alright, ratios can be simplified, and for the most of the ratios that y'all do, y'all have to simplify unless it's already simplified. Examples down here, it says a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Give each as a simplified ratio. So the first one they want us to do is trombones to trumpets. And like I said, we're going to do ours as fractions. So the amount of trombones they have is 16. The amount of trumpets they have is 40, so 16 over 40. Can't leave it like that though. They just told us we can reduce. What's the biggest number I can divide in the top and the bottom of this fraction? There you go, 8. That would be the smallest, sir. But thank you anyway. Divide by 8. On top you get 2. On the bottom you get 5. In simplified form, the ratio for trombones to trumpets is 2 over 5 or 2 to 5. And all that's saying is basically for every 2 trombones you have in that store, you have 5 trumpets. This is a ratio. That's how you simplify ratios. It should be familiar to y'all. Next one, flutes to clarinets. Flutes, you got 51 flutes. Clarinets, we have 39. Now looking at this one, at first glance you might not think you can reduce this one, but it's best to always try. And this one's kind of hard because of that 51, but I know at the bottom 39 I can at least divide by 3. I would just try up top to see if you can. If you can't, then you can, and you just leave it like this. But if you can, try to reduce. On this one, 51. 3 does go on to 51. How many times? 17. And on the bottom, 39 divided by 3. 13. So 17 over 13, or 17 to 13. So that's ratios. That should be simple for y'all. Moving on. Similar polygons. We just talked about a lot of this, but I'm going to re-mention everything. So the similar polygons with the same shape but different sizes. What makes the shape the same? The angles. Congruent angles make the shape the same. And after that, polygons are similar if corresponding angles are congruent. And also corresponding sides are proportional. And that word corresponding should be very familiar to y'all. We're going to use it a lot this year. We're going to use it again a lot in this unit. The ratio of corresponding sides is called the scale factor. Scale factor we're going to use a lot tomorrow when we do dilations. If polygons are similar, then their perimeters are also proportional. Alright, so this is all our wording up here. I'm getting some actual work down here at the bottom. It's a good note out here to the side to you for you too. It says scale factor, order matter. It does matter. I'm about to speak to that down here. So for 3 through 5, use the similar figures to the right. The first one, it says, what is the scale factor? It's number 3. What is the scale factor of triangle ABC to triangle DEF? And like they say, order matters. Whichever triangle they tell you to move to, from this one to this one, that's the way you go when you're doing your scale factor, if that's how they tell you to move. So they're telling me basically go from ABC, which was my smaller triangle, to DEF and write a scale factor. If that's the case, then I'm going to set up my ratio I just use the similarity statement. If this is the way they named the two triangles, ABC and DEF, it's the same as when we did congruency. You just match up the sides or the angles and you can figure out what to write. So keeping it simple on the first one, and I'm going to always start by writing a proportion, and a ratio in letters for y'all. So I'm saying AB is my first two letters of my small triangle over DE should give me a scale factor because those sides are similar and they are proportional. So AB over DE would give me my scale factor. The length of AB is 8. The length of DE is 12. Can't leave it like that though. We need to reduce, dividing by what? 4. Two over 3. My scale factor is 2 over 3. Whenever they're asking for scale factor, you want to leave that as a fraction. Alright. And this is why I say order matters. If you look at number 4, it says what is the scale factor of triangle DEF to ABC. So on this one, they want you to go from big to small. Just gotta make sure you set it up right. And you don't have to use the same size. You can if you want, but I'm going to just use different sizes to show you that scale factor is going to stay the same no matter what. Now we're going from big to small though, so it's going to be flipped. But I'm going to say EF over BC. EF would be 15. BC would be 10. Reducing, we got to divide by. That's 3 over 2. So going from DEF to ABC, my scale factor would be 3 over 2. Only other thing I want to show you is it don't matter what two sides you pick as long as they're corresponding. If you're picking the right two sides that match up correctly, you should get the same scale factor every time. Like say for the top one up here, instead of doing A, B, and DE, say if I chose AC over DF, that'd be 14 over 21. divide by 7, divide by 7. Still gonna get 2/3. All my sides are proportional, so no matter what two sides I pick, as long as I pick and match up correctly. Alright. Last one. What is the perimeter? Well, excuse me. What is the ratio of the perimeter of this triangle DEF to ABC? So in this one, perimeter of triangle DEF over the perimeter of triangle ABC. DEF, all the sides, 12 plus 15 plus 21 over 8 plus 10 plus 14. And then you add it on top and then on the bottom. On top, when you add that together, you should get 48. On the bottom, you add it together, you should get 32. And then we still need to reduce, of course. Probably hard for y'all to figure out what number we use on this one. Just use the biggest number you can think of. That'll go in them both. But for me, it's 16. I know I can do 32 divided by 16. I can do 48 divided by that too. And then I get 3 over 2, which is the same as our scale factor from just one side, DEF, of triangle DEF and ABC. What they're just really trying to show you is that the parameters are also proportional as well. Since each side is proportional, you're going to get the same scale factor. Alright, to the back. Similarity statements. Symbol for similar is this squiggly line right here. The one that we have over the congruent, or the equal sign, to make the congruent symbol. It's just that line, but I mean that's symbol by itself now. This means similar. So you gotta notice when you see similar versus when you see the congruent sign. And you should know which one, what they're telling you based off that. They tell you stuff is similar, you know that the side lengths will be different. They tell you they're congruent, they're exactly the same. Alright. A valid similarity statement must match corresponding angles and sides. Write a similarity statement for the triangles on the front. For that one, we already done worked with it a couple times, so you should know what the similarity statement is going to be. Triangle ABC is similar to triangle DEF. And from there, list all congruent angles and write a proportion that relates to corresponding sides. Okay. So we're going to list all our congruent angles on number 6 and 7, and we're going to write proportions for our corresponding sides. A proportion is when you set into more ratios equal to each other. So number 6, triangle XYZ is similar to triangle RYS. So I'm going to list all my angles first. Since these two are connected how they are right here, one is inside the other, I can't just use single letters to talk about angles. Like for example, if I call out R, I don't know if you're talking about this side of R or this side of R. So we need to use 3 letters for these. So on this one, the first one is XYZ and RYS. So I'm going to start there. I'm going to talk about angle XYZ being congruent to angle RYS. They actually share that angle. That's reflexive property. Up here, they lay on top of each other. This thing's looking good. Then, next, let's say angle YXZ is congruent to angle YRS. These two angles are congruent as well. They're corresponding angles too. Last one, angle YZX is congruent to angle YSR. Oops. And corresponding as well here and here. And then the size. You show those as proportional. So my first side would be XY over RY, which would equal YZ over YS, which would then equal ZX over SR. These are me writing my sides as proportional to each other. Faith, you want to do number 7? I was listening as you write. Go in order. Do angles first, Faith. And on Faith, on this one, since they're disconnected, you can name the angles with one letter. When we start you out, angle J is congruent to angle what, Faith? Thank you. Keep going. And then what else? Oh, so you did? You know what happened, I think? For me too? No, you good. No, it wasn't you. That was me. Like, no, I had zoned out. I was going. Reese. JK. Uh-huh. Over. No, don't listen to her. Do it yourself. You was doing good. JK over what? Thank you. Well. Uh-huh.
Okay, you know what? You do the rest of
Read some recording. Play this for your mama. Finish it, Faith. Ain't got time for you. I was gonna write it. Screw it. Alright. And at the bottom it says, using similar figures to solve for missing measures. I told you, if you ever want to figure out what we're going to ask you on the test, go to the end of your notes. These last couple will be stuff that you'll see. In the figures below, are similar with scale factor. I'm reading this wrong. If the figures below are similar with a scale factor of 2 to 3, find the value of x. So on this one, we tell you what the scale factor of the two figures are, 2 to 3. And then they want you to find the value of x. To do that, you need to be able to write a proportion. We've actually given you both parts of your proportion on this one. It's telling you that it's 2 to 3 scale factor on this one. And then they give you 42 on this shape right here. And on the corresponding side on this shape, they give you x. So you need to write proportion for yourself, which would be 42 over x equals, and then they give me my scale factor 2 over 3. I can just use that. So now that I'm solving for x, you need to know how to solve this. You should know how to solve a proportion. You should remember. I know you've been taught it before. Cross multiply. 2 times x is 2x. Over here, 42 times 3, 126. Divide by 2, divide by 2. X equals 63. So the value of x equals 63. And that works out. Just to show you too that it's going to be proportional with 2/3. You don't have to, I mean, this isn't part of it, but I'm going to show you. 42 over 63. If I wanted to reduce that, I could divide by 21 on top and bottom. And I get 2/3 as well. So it is, it's check size proportional. But your answer is x equals 63. Slide over. On this one, it says given KLMN is similar to PQRS, find the missing variable. So on this one, we want to find x. Both of these figures, and they give you the two sides that you need. You can just match up to make sure though. Like on the first figure, they give me LM, and LM goes with, based on my statement, QR. And then I can set that equal to KN, which was that other expression. And KN matches up with PS based on the statement. I'm just writing that so I know how to write my proportion. So I write my proportion, whatever I have on LM, I'm putting here. So 4x plus 4 over QR, which is 48, equals, and then 7x minus 9 over 60, which was PS. And then from there, you need to cross multiply. This one is a little bit more entailed because it got expressions on it. I would rewrite this before I sit there and try to distribute. I would rewrite this, make sure I'm looking at it correctly. So 4x plus 4 times 60, I would write this out here. 60, then in parentheses 4x plus 4 equals, Then on the other side, 48 times 7x minus 9. So 48 in parentheses 7x minus 9. I would write it this way so I can see it that way. And then from there, y'all should know what y'all have to do. Y'all need to distribute. On the left side, 60 times 4 x is going to be 240 x. 60 times 4 is going to be 240 equals, on this side you got 48 times 7x. I think we got 336 last time. X. And then 48 times negative 9 would be negative 432. So that's my equation after I distribute. Numbers are big, but you should be able to handle them. Then from there, now you got variables on both sides of the equation. You need to move variable first. Subtract 240x, the whole thing. Put it on this side, on the 240x, cancels. Bring it down 240. Here doing this math, you get 96. No, not 96. Oh yeah, 96. Is that right? It's weird to me. Oh no, it ain't. No, yeah, it is. I don't know why I don't trust it, but 96 minus 432. And then from there, add the 432. I'm gonna run out of space, so I'm gonna have to move over. 240 plus 432 is 672. So move up here, y'all. 672 equals 96x. And then I'm gonna divide by 96. This was a longer equation, but y'all should know algebra, so if not, you're behind taking the test on Wednesday again to try to prove that maybe you should know algebra. Not we, y'all. Not we. Some of y'all, 40% of y'all. Okay. I'm still recording. Watch your mouth. We're almost done. On that one, anybody had any questions? I know there's a lot going on in that one. I can explain. I think I did an okay job on this one. Sliding anyway. Number 10, this one I want you to pay attention to. You will see something like this on your test too. And kids make this mistake all the time. This one, when you have a triangle inside of a triangle like this, a lot of times you have to make adjustments. You can't just roll with what you see. You should be able, most of y'all should be able to figure it out though. So it says ABC is similar to ADE. Find BC. BC is the side right here with the expression 2x plus 2 on it. So basically you find x so I can plug back in and get the length of BC. Before I do that, I need to write a proportion. They gave me numbers only on two sides. They gave me numbers on BC, which is the long side on the bottom of the big triangle, and then DE, this side on the bottom of the smaller triangle. And then they gave me A to D and D to B on this side right here. So let's see if you figure out what to do. I'm going to tell you how I would set my proportion, and I'm going to see what y'all do. So I know I need to find X, so I'm going to use BC. So my setup is going to be BC over the its similar side, which is DE. And then I need to do, since I did BC, which was the big one, over DE, then I need to do AB over AD. So I did BC over DE, and then I'm gonna do AB, excuse me, over AD. Let's see. Ms. Johnson, you mind setting this one up with me? What's BC? That ain't no trick question. What am I gonna write for BC in my proportion? Thank you. Over DE, which is what? Okay. And then so that equal to AB. What's AB? What you said? How you got that? Good. This is where most people mess up. A lot of y'all are seeing it though. They ask, I need AB, which is the full side here. It's just 28. 28 over AD. Thank you. Most people don't make that adjustment on this problem. And sometimes you might have to go the other way. On your practice, you'll see it when you get there. If you're behind, actually do your work. You're going to have to go in reverse. In a practice, like for example, they'll give you the whole thing, AB, and they'll give you this little part down here, and you'll have to find AD. So, like, say the 20 was missing, and they gave you 28 and 8, you have to notice you need to subtract to get this piece, AD, which is 20. You have to go in reverse. You'll figure out what you need based on what you, when you see it. If you're thinking. If you're not, you're just going to mess it up. Cross multiply, cross multiply. We could rewrite this one, but you might be able to do this distribution in your head, but I ain't going to trust that. I'm going to rewrite it. Cross multiply is going to be 20, parentheses, 2x plus 3 equals, on that side, 15 times 28. I think they told me 420 earlier. Yeah. Then you need to do that distribution. Distribute. This is 40x plus 60 equals 420. And then solve that equation. Minus 60, minus 60. 4x equals 360, yeah, then divide by 40, divide by 40. Cancels, x equals 9. But make sure you're behind on box that. Don't stop there. The question didn't ask you for x. The question asks you for BC. So BC equals 2 times 9 plus 3. BC equals 21. That's what I want to box. Slide no. Last one. Man, cannot get over this cold. I know. Especially when you're out there talking to the kids at lunch. 11. Given the similar polygons, triangle JKL and ML, find the missing measures and the perimeter of triangle NML. So I want to find X and Y, and then I want to find the perimeter of the smaller triangle NML. To find the perimeter of the smaller triangle, I need to know that value of Y, so I can add all those three sides together. Let's get X and Y first. On this one, you need to match up so you can write a proportion. You need two ratios to write a proportion. One of your ratios is going to have a variable in it, so you got to make sure the other ratio has just two numbers in it. Can't have two variables in your ratio in your proportion. How can you solve it if you got two different variables you're looking for? So you need to make sure you understand that when you're setting this up. So when I'm doing my setup, I know on my first one I need to find X. So on X, that's KL. So I'm gonna just write out what I'm gonna set up. KL over, I'm gonna match up the other side, which is ML, and then I'm gonna set that equal to. So since my variable is in KL, I know my other side has to have two numbers on it. The reason I say that, when you're looking at this to figure out what other two sides you want to use, like if you start with this JL one, you need to understand JL goes with NL. And JL and NL has the Y on it. I can't put another variable here. I already got X. So I can't use these two sides right here, these two corresponding sides. I'm not using that for my proportion. I'm going to use this one here. I'm going to use JK and NM because they got two numbers on it. So I'm going to set that equal to JK over NM. And that's how I'm going to write my proportion. The first one to solve for X. So KL is X. So I'm going to say X over, ML, which is 14, equals, and then JK, which is 40 over 16. I don't know why I put my equal sign way up there. Sorry. It's a weird equal sign. Cross multiply. 16x. 560. Divide by 16. Divide by 16. X equals 35. So I'm gonna box that because that's one of mine. I gotta find X, Y, and the perimeter. So that's one thing right there. That's the X. Now that I got X, I can write that in on here. I know that KL is 35. I know that this equals 35 right here. This length for this side. I could use that if I wanted to. I could use 35 and 14 now to find my Y. But I usually stick with the same thing that I've always started with. Like my second ratio, I would use 40 over 16 again because I know I can use that because it was already given to me. But now I just need to set up to find Y, and I gotta make sure I do it right too. So I'm gonna rewrite what I'm gonna set up over here again. So I've been pulling left to right based on the way my statement is written up here. I've been pulling my stuff left to right this way because JKL is on the left, NML is on the right. I'm saying this all for a reason. You can understand, because my kids last year and the years in the past have always thought the variable is supposed to always go on top. Not necessarily, depending on how you set up your ratio. So Y is on NL. NL matches up with JL on my first triangle. So when I write this, it should be JL over NL equals, and like I said, I can use the same ratio I had for the last one on the other side, JK over NL. But you need to understand, that being said, the way we've written this, our variable is not going to be on top. And this one, JL is on top, so it's 45 over my variable Y equals 40 over 16. Like I said, my kids last year used to always think the variable always goes on top. It does not. It depends on how your setup is. And then from there, cross multiply. And it does matter too. If you put the variable on top, if you write this part like this and write this Y over 45, you're going to get it wrong. So 40Y equals 70/20. Thank you. Divide by 40 cancels. Y equals 18. So now we know the value of Y too. Y equals 18, like she said. I can write that up here. Y equals 18. And the last thing they wanted me to do was find the perimeter of triangle NML. For that triangle, my lengths were 14 plus 16 plus 18, the one we just found. What is it now? Okay, so the parameter is going to equal 48. So that's my three answers there: X, Y, and my perimeter. But that is the expectation. Alright, I'm recording this too, so chill. Hey, number 6, it's on the practice sheet. Number 6, you got 2 images on the graph, and they want you to find scale factor. Whenever you find a scale factor on the graph, it's a little bit different. on the graph, when you find a scale factor, you want to go image over pre-image. But let's talk about this first. Let's read it. It says trapezoid QRSP is transformed to create trapezoid FGHE. Determine the scale factor of the dilation performed on this one. So it is, and we'll talk about dilations tomorrow. It is a dilation because the image, actually they say they went from the QRSP image to the FGH one, E. It got smaller from here to here. So this is a dilation, which is considered a reduction. But we can still find a scale factor off of this just by being able to count. But what you need to understand, your scale factor has to be image over pre-image, and y'all should. I'm gonna write that down for you. It should be your image after the transformation over your pre-image, the one you started with. That's how you're gonna write your scale factor. You can pick any two sides that are corresponding. Only thing is, I wouldn't pick any sides that are too hard. Like, I know it's natural to start out with the first couple of letters. So understand too that my image is my smaller one. That's the one that it got reduced. I mean, it started out here QRSP, and they said they transformed it to create FGH, whatever. So I'm doing this over this. But I wouldn't. The first side on there is called FG. If you look, FG is slanted. You can't count a slanted side. Y'all know y'all will have to do Pythagorean for that. You don't need to do all that. Use one of these straight sides. Pick another side. I would go to the next two letters, GH. GH is this side right here. It's on here straight. I can count that. So I'm going to say GH. My bad. Let me go back over. I'm doing GH over RS. Matching up those two sides. The length of GH is 1, 2. So 2. And the length of RS, which is this side right here, is 1, 2, 3, 4. So this is 2 over 4. 2 over 4 reduces down to what? I'm sorry? Huh? For real? You lying. Oh, I ain't never paid attention to that. It don't even really matter though. Let's do it right though. Thank you. So GH, I'm sorry, that's 2, 4, so that's 4. It ain't gonna matter. 4, and then this is counting by 2s, 2, 2, 4, 6, 8. So 4 over 8. So instead of dividing by 2, let's divide by 4. And it's going to reduce down to what? 1/2 still. Scale factor is going to be 1/2. Thank you for getting that for me. I ain't even pay attention to what it's counting by. On this one, it's lucky enough that it's going to come out to be 1/2, so it ain't really going to matter. And then even if you needed to pick another pair of sides, you could have picked any two pair of sides. Like say we decided to do, what is it, HE? No, not HE. FE and QP. Say if we decide to do FE over QP. FE is 1 space, so that's 2, because it's counting by 2s. And then QP would have been 2, 4. So it would have been 2 over 4, and that would have reduced down to 1/2 as well. You don't get the same scale factor. You just need to match up two sides that you can count. That's all you got to do to find scale factor. Only other thing I need to make sure y'all need to understand what's on the graph, once again, is image over pre-image. You got to make sure you do it that way. Understand which one is the image and which one is the pre-image, and do the image over the pre-image. It's the main part I need you to get from that. Alright, anything else you should be able to do? Use your notes, please.